Okay. Did everybody get this? Anybody has a problem or a question? You tell me. Okay, these are your relative min and your relative max. Because this is your relative max, your relative min. Sometimes it helps to label them. This is A and this is B. Your relative max is your A. Your relative min is your B. Of course, my board is off. Okay, so that you can label these and you can identify them. It's nicer to put, I like to put them on here because it allows you to, wow, it erased my whole thing. Okay, you want to erase. It never erases my work in there. New things happen every day in here. And odd and even, everybody good with the odd and even? To replace it with the negative x? Also, do a visual. If it's going to be a reflection over the y, it's even. A reflection through the origin, it's odd. And you can always tell by if you pull one point up here, if it's the negative down here, then you know it's odd. We looked at that in your calculator as well. Can everybody do the intercepts algebraically? You gotta be able to do them algebraically. Okay, number 3. Number 3, this is also a chord graph, a cubing chord graph from that. And this time around, your max and your min were the first one, the top, your max was irrational. So make sure you go 3 decimal places. Rule of thumb, 3 decimal places. And your relative min worked out nicely. So you can kind of tell from this can't be odd or even, because if that was the case, these 2 points would be the same with opposite signs. So you know this is not an odd or even. Make sure you plug it in and you prove this. After you do this, 2 things. You can either say, okay, this is not the original, so it's not even, and then go back to your original. Did every sign change? Nope, not every sign changed. The sign in the middle didn't change. The one with the even exponent is not going to behave the same way that the odd exponents behave. So you know you got an issue if you have even and odd from one equation. Good questions? Looks like you guys were doing the right thing there. As long as you, it is a lot more work, and if I give you a quiz or a test, I'll ask you for the parts. Like I don't expect you to, memorize what else was I supposed to put here. I'll ask you for the parts. Give me the intercepts, give me the range, give me the domain. I'll label them for you. But in the meantime, sit there with that sheet that we do, and that'll kind of walk you through that. And then the last one. This was a nice function, and this was a nice even function. And you can see right here, your reflection over your y-axis. When you negate the x, the y is the same. So you can see that right there. When you plug it in with the negative, it comes back to your original one. Make sure you do the intercepts algebraically. Every year, I have a couple of stubborn kids that say to me, but I found it on my graph. I found it in my table. Yes, you verify everything with your calculator. You verify. Our goal with sketching is pretty soon you're not going to need your calculator to do a lot of these. Granted, those mins and maxes, yes. Okay, and again, we're going to see this should give me 4 roots. My highest exponent gives me my roots, and they may not all be real, but right now ours will be real. Questions at all? No? Okay, let's take a quick look at that other one. Let's take a quick look at your odd and evens and make sure you were okay with this. left off on the bottom somewhere. See if you had any questions about these. You can always verify them by graphing. And they kind of give you a nice little puzzle on the bottom to take your number of evens and your number of odds and to see if it comes out to be their answer. And then you know you had the whole sheet right.
Will Ms. Gabriel please call the office at extension 354? Ms. Gabriel, please call the office.
Questions? I can't move it up any further. Okay. While you're doing that, I'm going to hand out today's work. Like over the last couple of years, the kids always moan and groan, oh, I didn't like that. But when we do it in here, it's a little bit different. So it doesn't seem as bad. I don't know, does it seem a little bit better this year? Plus, I think once you're exposed to it, like that part of it's over. You're not like panicking over, oh, I never saw this before. You know, there's kind of a little comfort zone now, if you will. Okay, these are your core graphs. Sometimes we call them a parent graph. In Algebra 2, they went to parent graphs. We do all our transformations off of these. So when I give you an absolute value function, we'll go back to the basic absolute value and see where the transformations are. And you'll be surprised how you can graph it without your calculator. So your basic graph, and write these out for me on your paper, is your absolute value core graph. And we'll write down all its characteristics as well. Basic, parent graph, core graph, whatever you called it before. I tend to call them a core graph. Now, the domain for this guy says there's no restrictions. You can use all real numbers. Your range, however, says I'll never get negatives out of my absolute value. So for the basic absolute value graph, your range will be from 0 to infinity. When we shift it down or up, we'll change our range. When we shift it left and right horizontally, we would change our domain. But in this case, your domain will still remain all real numbers. So we kind of work off of this so that later if we shift it down 3, we subtract 3 from here, we have our new range. So if you stay with your basic core characteristics, it makes your transformations just a little bit easier. It makes your reflections easier. It makes all your transformations a little easier. Now, when we start doing your transformations, I usually ask you to graph your core graph and then graph your transform graph from your core, rather than put it in your calculator. And I'll show you step by step how you can check it in your calculator, but you'll have to name each individual transformation. So this is like the best way to be able to do this. Okay, your squaring function is next. Your squaring function is your quadratic. This is your parabola. We square. Basic, without anything extra in here. This is your basic parabola. And if you kind of get the way the parabola goes, it kind of helps you. When you do the absolute value, we sketch, so that really doesn't matter. But if you kind of think about it, this is your 1, 1, your 2, 2, your negative 1, 1, your negative 2, 2. It kind of has a 1 for 1. Your parabola goes a little different. It starts at the 0, 0, goes to 1, 1, then goes to 2, doubles 4. So it kind of is not as sharp as your absolute value. It's rounded and a little further out, because it does a 1, 1, then a 2, 4. So your absolute value is hidden here from your parabola. This domain again, what would the domain be for this? All real numbers. We have no restrictions on this. Anytime we square, and this is just your basic function without any other terms here. When we square, we're not going to ever get a negative out of this. So again, our range is from 0 to infinity. Your vertex in this case, 0, 0. Okay, these are your basic core graphs without anything else going on. your square root function. Your square root function says basic. Now, just no other things happening here. Now, because of your domain restriction, you know that you can never have a negative underneath your radical. So you take this out and you set this greater than or equal to 0. So your domain has to be from 0 to infinity. Automatically, we know that. Could we also ever get a negative out of this radical? No. So your range is going to be 0 to infinity. Your graph is going to look like this, like a little arm that goes this way. It's using all the positive x's, it's using all the positive y's. For a graph, without anything there. But you know your domain restrictions, so you can figure out your domain even before we get there. And cubing function. Your basic cubing function says x cubed. It goes like this. It comes from down here, switches a little like this, it comes up. When A is positive, if this is positive, it's down on the left, up on the right. When it's negative, it's a reflection, it will go the other way. So this is your basic core graph for your cubing function. Your domain is all real numbers, and what's your range in this case? All real numbers. Good. So the nice part about this one is if we do a transformation off of this, we're not going to affect the domain and the range. And your last one is your rational function. These you probably didn't talk about last year. Your rational function is your fraction. Now, you know we have a domain restriction. So what can x not be? 0. So if we set this equal to 0, we say x cannot be 0. Take this out of my domain. So my domain says negative infinity to 0, or 0 to infinity. I cannot use the 0. It's going to take a break right there. Now, your rational function is going to look like this. It has an asymptote. This is your asymptote, here and here. It can't use an x of 0. So is there any way that I can get a y of 0 out of there if I can't use an x of 0? Is there any way to get a y of 0? No. So it's also not being able to use the y of 0, ultimately. So it's taking an asymptote jump here. It's making this give you your boundaries for this. And we're going to talk asymptotes as well. But your basic rational function looks like this. And your range does the same thing, therefore. Your range says there's nothing there that's going to give you a 0. Nothing that I can put in to give me a 0. Okay, these are your basic functions. Now, here's your transformations. And I gave you a transformation sheet. Anytime, and they all behave the same way. Regardless of what your parent graph is, it behaves the same way. Anytime it's outside that parentheses, it's going to be a vertical shift, up or down. Anytime it's inside the absolute value, underneath your radical, in the parentheses for your squaring, it's going to have a horizontal shift. And the horizontal shift goes the opposite way. The opposite way. If you think back to your circles, that's the equation of a circle, right? What's the center?
Negative 2, 3.
Negative 2, 3. It comes out the opposite way, right? So these behave the opposite way as well. This would shift to the negative to the left. This is also going to behave the same way. Any plus is going to go to the left. It behaves opposite. So we're going to take those transformations and apply them to your graphs. Once we start working with them, they look a little bit better. So we start like this. First you look at what's your core graph. So what core graph are we using for this? The parabola, the squaring. So we start off like this. So your basic graph went like this. This is outside of the x. So your vertical and your horizontal shift is going to apply here. So which one is it going to be? A vertical or a horizontal? A vertical. When it's outside, it's going up and down. A vertical. So this says, take this and move this up 2 units. Everybody moves up 2 units. So all we do, since we're sketching, is figure 2 units up and we sketch. There's our graph. Our original domain for this guy was all real numbers. Our original range was 0 to infinity. Did the domain change with your new transformation? Nope. So your new domain is all real numbers. Watch how easy it is to change your range. Anytime you go vertically, make your hand like this, you use the Y. So you moved your Y up 2. So you come here and you add 2. So your range is now 2 to infinity. Use your original attributes for this. It helps find the new ones. This guy's different. This one's inside the parentheses. So this says, here's my basic graph. Here's my basic graph for my squaring function. And this time, where am I moving? Horizontally or vertically? Horizontally. Which way? Left. It works the opposite way. So I'm moving this guy to the left, and I just made my parabola. 2 to the left. Did I affect my domain? Nope. Normally I would have to take, move 2 over, but my domain is all real numbers. My domain stays the same. Did I affect my range? Nope.
No.
My range stays the same. Only a vertical shift will affect your range, because that's your y. A horizontal will affect your x. So we can graph these guys without using your calculators, just by their attributes. There's a reflection. Let's see if we can just put the reflection into that. We have about 5 minutes. 6 minutes. Okay, reflection. And this is what we talked about before with your reflection over your y-axis. Remember we talked about your y? That your x is negating, but your y was staying the same. And then through the origin, your y was also negating. We talked about this. So it depends where your negative goes. If your negative is next to your x, go like this with your finger. From positive x to negative x, where's your reflection? Y-axis. If it's away from the x, that means it's affecting the y. Go like this. Y goes positive to negative. Where's your reflection? The x. So do you see it? You see how to remember those? Don't memorize, visualize. If your x is negating, you're over the y. If your y is negating, you're over the x. So out here, which one am I affecting, the y or the x? The y. So here is my basic core graph. This is my basic core. Where's this going now? If it's reflecting, if it's the y is negating, the y is going from positive to negative. Where am I reflecting over? It's the x. So it's going to be right here. This is my new graph. Did I change my domain? My domain still stays the same. I can only use the positives, again, and 0. Did I change my range?
Yeah.
Yes. I negated it. I switched it. I took the opposite of. That's what the negative forces you to do. So the original range said 0 to infinity. You reversed it. this range is going to say negative infinity, stop at 0. You took the opposite. Instead of the top, you took the bottom. Okay? See your difference here? Your difference in this one, watch this one. Don't pack it up yet, guys. This one says my x is negating. So my x is negating. X goes from positive to negative. Where's my reflection? Over the y. So instead of that, down here. It's over here. This guy. So did my domain change? Yes? Now I'm negative infinity to 0. Did my range change? No. Okay? Alright. Probably at the time set. We'll do the stretches and strings tomorrow because they're a little bit more confusing. So for homework, you should be okay on your homework. You should be okay to do your homework. Yeah. The only one you probably can't do is the very last one.
On the front page?
On the last page. Number 14. You probably can't do number 14. Because that's got a right for string in there. So do all but number 14.
And you can check them in your calculator, right?
Yes, you can absolutely check them in your calculator. A good thing in your calculator to get guys